Folks, thank you very much for joining this session about serverless platform on Kubernetes. We will be doing a bunch of things here, talking about Kubernetes mostly. So let's start with the basics. Kubernetes users? How many people using Kubernetes already? All right, that's good. That's fair enough. Most of the time, because this is KCD Spain, it's about Kubernetes, so I will not be going through the basics. But if you have any questions, please feel free to shout out, and we can stop and spend a little bit more time there. I will be showing a bunch of different projects, and I have only 15 minutes, so it's it's going to be fast. And the main idea here is just to show things, and then you can go and research more, you can ask questions, or you can ask for more clarifications. But I wanted to show a bunch of different things. Important when we talk about platforms, basically we are talking about combining a different set of projects to kind of like achieve something, to enable different teams. And what we are going to be talking specifically today is about serverless on top of Kubernetes, which is a specific thing that some people might want and some people, basically, they are not interested. So it's not for everyone, but I think that it has some advantages that you might consider at some point. So my name is Mauricio Salatino. I work for a company that's called Diagrid. I will be talking about the project that we're working on a little bit and also the products too. Not too much, just to mention kind of like the ideas behind these and other companies and other projects. I'm a software engineer. I'm not a developer advocate, so my presentations tends to be not funny and very technical and technical oriented. So it will be just very dry way of showing different projects. I'm also a CNCF ambassador, and I think that's interesting, mostly because I've been just working with different projects, and I've been talking about this for some time now. And I authored this book. I have 2 copies. We will be playing with the Wi-Fi in a bit, just to see if you can get one of the 2 copies that I have here for free. But if you're interested in platforms and Kubernetes, this book basically covers, like, I think that like 17 different projects in the CNCF space and some projects that are not in the CNCF too. And as I mentioned before, I'm collaborating with different projects, and I've been involved with the Dapr project, with the Knative project that I'm showing today, and also with Captain, something that I'm not showing today, but it's also like a project that it's very close to my heart. I've been running a blog for 15 years, so if you are interested, check it there, like Salaboy or Salaboy at Twitter is my handle. But let's get started. Let's take a look into some open source projects. So the first thing that I will do, which is something that I usually don't, is showing a project that's called Open Function. How many people here knows about Open Function? I see 0 hands raised, and there is a very good reason for that. Open Function is a CNCF project, but it's a Chinese-led CNCF project. That basically means that it was created in a Chinese community and donated to the CNCF. And it's a very, very interesting project to analyze. That's why I wanted to show it today, mostly because when we're talking about serverless, some people will think about like function-based applications and platforms, and Open Function gives you exactly that. So let's take a quick look at how this looks in practice. Let me see if you can see my screen here. I'm connected to a cluster. I basically install Open Function into a Kubernetes cluster. This is running on GKE, on Google Cloud, so it's not in my laptop, meaning that if the Wi-Fi goes wrong at some point, I will just not be able to do anything. We will try 4G or something else. But it's kind of working, right? When I just basically list all the namespaces, you can see that I have a bunch of things. I've just installed Open Function, which is just a simple project, and I have a bunch of different tools installed there, just to be able to provide this like function experience. The idea here is to enable developers just to write functions in any language that they want, and then just by creating a single Kubernetes resource to be able to get that function running into this Kubernetes cluster, right? But in order to achieve that, they actually integrated a bunch of tools together in a very, very particular way. The main interface that you will see as a user, it's something called function, of course. And I don't know if you can see this like in the back, but I will try to make it as big as possible. Everything is in a repository there that it's called KCD Spain 2024. In my GitHub repository, I will share the link later. But as you can see here, let me see if I can, As you can see here, there is just a new Kubernetes resource called function. That's the thing that you define now in order to actually deploy a function. Then basically you write the function code. In this case, I have a Go function, which is pretty simple. It's just printing a hello world or something like that. And then you define 2 things here in the spec definition, in the spec template here. You define the build phase. How are you going to build this code into a container? And then you define how are you going to serve this code for people to access this function, right? As you can see here, the build side of things, you need to specify a builder. In this case, you need to know that it's Go. And this builder, I think it's using a CNCF project that it's called buildpacks to actually do the build. And as you can see here, you start seeing this kind of stuff, like, okay, if you're in China, maybe you cannot access the Go modules, so you need a proxy for that. Kind of like interesting stuff that happens in the other side of the world. But another important part here is not only how are you going to build the container, but also where is the source code. And here I'm pointing to a GitHub repository that has the function source code, in this case, again, written in Go, under this directory. So no matter where the cluster is, it's going to be able to pick up the source code of the function, build it, and deploy it into the cluster itself. And it's going to then serve it here. We don't have much parameters here. In general, it's just the name of the image that will be created on demand by the build process. And then the fact that we will, we can configure the image here in any way we want. If we want to set up environment variables or whatever, we just set it up there. And then the port that it's being used by default. So with this thing, I will just apply this to the cluster. So basically, not that one, this one, functions, go, functions, go, function.yaml. So I'm just applying this resource to the cluster. And basically what I have now is a function that is going to be built and deployed inside this cluster by using a bunch of different tools. If I can do get functions now because this is a resource, right, like as any other Kubernetes resource. And I can see kind of like the state of the function itself, right? So it basically says it's being built, it's building now, and at some point it will tell me if it's been served, if it's ready to receive requests or not, and I will get some kind of address here after all this process happens. I did build this function before, so I wasn't expecting this to be built again. Things that happen when you are doing kind of like live demos, right? But at the end of the day, you will have a URL there that you can basically interact with. Just call it, it will be some sort of a public URL that you can access. If you have configured your cluster correctly, you will have a public URL, or like an internal cluster URL that other functions can use to call this function. One thing that I wanted to show here, which I think is important, if you go to their website, like openfunction.dev, you will find this diagram, which for me basically tells me a lot of things, right? It tells me that to build an experience like this, where you basically expose an interface, the function interface, in this case, the function resource, and then you will have different options to do different things depending on what you are trying to do, right? If you are trying to build the container based on the source code, you have a bunch of CNCF and open source projects that will help you to do that. Build packs is very, like, it's a complicated project. It's not a simple project, but the main idea is that you don't even need to specify in which language your function is or your code is. Build packs will have a detection mechanism to say, this is a Java function or this is a Go function, and then we'll create containers based on that, which is a pretty interesting mechanism. And then the other ones are kind of like more typical things that you will use just to create containers. The main idea there is just not to be playing with Docker files, right? Like, which are good. They are easy to create, but they are also very easy to make mistakes too. And then you go through, the phase of, okay, I have a container. Now I need to serve this function in a way that, it's serverless in a sense, right? Like, and the main idea here is that I will be able to upscale the function if it's getting a lot of requests, or I will be able to downscale it to 0 if nobody's using it, right? And for that, you can see there that they are using a bunch of projects. And again, it's not just using the projects, but it's combining them together to achieve some use cases. So for some specific use cases, you need to combine them in a very specific way. You can see Knative there, you can see KEDA, you can see Dapr. And at the bottom, they added also like a WASM runtime too for WASM modules and stuff like that, which is kind of interesting. And then on this side of the screen, you can see events, which is, again, it's a way that they created in order to connect functions together via messaging or eventing, right? It's kind of like an interesting thing too that they created. And again, this is where it becomes all about, like, is this something that you really need? Like, do you need the functionality in this way? Or are you willing to create your own glue between the projects and define the use cases that you are trying to target in your company? Let's see, and I will just not wait for too long. Let's see if this is running. I don't know, demo gods are on my side today. So it seems to be running here. I don't know if you can see down there, but like, basically what I have here is a URL that it's not a public URL. This is basically an internal URL. And this is where open function, you actually need to start understanding a little bit about the tools that it's using in order to use it. Because when things go wrong, abstractions start like falling apart. Because if I need to troubleshoot or figure out what's the public IP for that function, I need to know how it's being served in a way. And I will just run a command because I know how this is being served and I know where the public IP is. But yeah, at the end of the day, you don't really want to do this. So you need to make sure that whatever you expose here, it can be used, right? And I can call this function now using just sending an HTTP request, saying KCD Spain, for example, right? As you can see, the function will not respond pretty fast because it wasn't upscaled yet. So there wasn't an instance of that function running. And it took kind of like a second to spin up a new replica, process the request, and then it's now waiting for more requests to happen, right? If I call it again, it will be much faster, right? I can list the pods here. You will see that now I have, let me see if I can do that. You will see like I have that pod running there, and again, in the true serverless fashion, after 90 seconds or so, which is the default time for this to be downscaled, if I do not send more requests, this will be downscaled to 0. Right? And again, as I mentioned before, there are some tools that are basically implementing this behavior, and it's actually up to you to define if the way that open function is gluing things together works for you or not, right? Open function gives, like, for me, it's a great initiative. Again, there are some, languages barriers that we need to tackle because, again, all the documentation, it's a little bit strange being translated from Chinese to English. There is tons of possibilities there to contribute, to make things easier for non-Chinese speakers and for, for Spanish speakers as well. It provides this abstraction based on a function concept, which is great, and I think that they did a good job there at gluing some tools together. But then, of course, like when I see companies, like large companies creating their own abstractions, they probably have something, they need something similar to that, but not 100%, right? I think that having an interface called function actually limits the kind of applications that you can deploy because you think that you can only do functions like lambdas or stuff like that. But actually, no matter what container you put in there, it's going to be served and built in the same way. And then you need to figure it out, like if the tools that Open Functions is using, are you comfortable with those tools? Do you know about those tools or not? Because at some point when things go wrong, you will need to troubleshoot them. So you will need to maintain all that stuff together. And I see people using GitHub Actions to build their containers and then using GitOps to do the deployment of things. So having this tool that basically you send a resource and then you just get something built in the cluster and then deploy in the same cluster might not be the right thing for you for several reasons. So, it's a trade-off, right? Like, I mean, at least for me, just seeing how people is gluing these tools together, it's really important because it shows me a set of use cases that are well tested and well adopted. But then to choose these for real scenarios, then you just need to figure it out if that's the good thing for you or not. And in order to go and talk a little bit about the tools that are being used by Open Function, we created an example here, and this is where we do the dangerous part of the presentation. We are going to use HTTP and not HTTPS. So if you scan that QR code, you will be able to access kind of like an application, and I would love to see if we can play together for a bit. So let me know if you can access. You will need to accept that it's an HTTP endpoint and not HTTPS. You will see the warning there. Please accept it. If I have 2 people pressing buttons, I think that's more than enough. So I see phones up. I will take the QR code in a second. Does it work? Somebody got it working? Yes, I get some thumbs up. So let me switch here and switch to the application itself. So the application that you're accessing, basically, it's the simple thing. It's a simple dashboard to vote, and we have kind of like the real-time events popping up every time that somebody submits a vote. And then we have some calculated views of who is winning, cats or dogs. We have dogs people here in the room, so I'm super happy. This application is really simple. When you voted, you had like a hash code generated, so don't close that window. Look at that, that's going insane, that's awesome. So don't close the window because with that you can win a book at the end of the presentation. Great, so the application is working. Again, that application is running on Google Cloud. The architecture of that application is super, super, super simple, right? So we have a vote service. That's the one that you're using from your phones. It has a UI, but also basically what it does on the backend, it just sends data to Redis to store your vote. Like, you get the JSON payload with the vote, then you store it. And then at the same time, we send a RabbitMQ message to just to a queue that it's being picked up by the dashboard that you see where all the cats and dogs are popping up there. In the middle here, we have a worker that doesn't have any user interface, and it's doing kind of like a cron job, right? Like every 2 seconds, it's picking up data from Redis and translating that into a view to PostgreSQL. And that's being read by the results UI that it's basically showing every 2 seconds, the percentage of the votes. Pretty simple stuff, and as you can quickly see here, when I see this architecture, I don't think about functions in general, because I have user interfaces. I don't want to be waiting, to upscale a function to be able to show a user interface. That should be up, at least with this one replica running all the time. I have some infrastructure like Redis, RabbitMQ, Postgres that needs to be running somewhere and I need to manage. And then I have, some web sockets going on back and forth. Again, another reason why a function might not be the best thing if I need to keep these bidirectional connections open just to send notifications. So how difficult it could be to build an application like this? It's a little bit hard, but the main problem that I face here is that, okay, we need to create containers for all these things. We need to connect to all this infrastructure. We need to make sure that somebody creates environments where this infrastructure is ready for me to develop and all that stuff. So let's talk a little about the projects that are being used by Open Function and the reasons why they chose to use those projects. The first one, Knative. How many people have heard about Knative before? Okay, so we have half the room or a little bit less. So Knative is usually associated to serverless and to auto-scaling, basically. The main idea with Knative is to be able to go from container, right? Like I have a container and I want to serve it in a URL. So if you give me a container, I will just give you a URL where this container is being served. And I will manage, as a Knative project, I will manage the life cycle of that container in a way that I can downscale it to 0 if nobody's calling it, or upscale it if I'm getting a lot of demand. This is something that happens with Keynote sometimes, that you cannot get out of the presentation mode when you are presenting the screen, which is super interesting. It's really interesting. And then you said, okay, what do I do? One way of dealing with this is maybe that, but not really. So I'm just connected again and just praying that it will work. Well, and it doesn't react to my clicks either, right? It's just going forward, which is super interesting. This happened to me before, and I don't know why. So let's play with the demo gods. This is not even demo gods. This is Keynote gods, right? This is insane. All right. Think. What do you do when nothing works? Turn it off and turn it on again, right? I've done this before. Let you go. Oh. Let's see. So basically now it's unblocking. I'm blocking my screen, right? And this is super fun. Yeah. That's the thing that happens. So what I can do is I actually can continue without slides, which was my original idea. But that will not work. Let me try. Let me try hard reset. We can wait, right? So Knative again, it's associated with that upscaling and downscaling applications. There it goes off. I will unplug this and then see if it works. Yep, so it's bootstrapping again. Again, Knative is upscaling, downscaling applications. How does it work? It basically works by injecting a sidecar into your application and basically monitoring incoming requests, HTTP requests. So you have a proxy in front of your application basically looking for HTTP requests, and it will basically extract data about those requests and inform the Knative control plane, the things that you install in your cluster, about how many requests are you getting, and if you need more replicas or less replicas to serve all those requests. It's a very sophisticated mechanism, and it's a very mature project that it has been tested a lot, and it's been adopted by a lot of companies and a lot of products, which makes me think that it's mature enough for people to use. And now it's reaching to a point where it's being graduated in the CNCF, which basically means that there is enough adoption to justify the use of these tools. So no more Keynote for me. And I will probably need to authenticate to all the services again. I don't even know what that is. That's probably Slack. But the good thing is that we get my computer back again, so I can keep showing demos and stuff. Let me see if documents maybe. Nah. All right. Yeah, there you go. Not there. That's really good. Okay, let's try Keynote again. Why not? Why not? Keynote. KCD Spain. Let's see. All right, I was there. So Knative, how does it work? You deploy a service. They have a new kind of resource. I don't even want to go in full screen anymore. But let's try. Why not? So you have a thing here. You have a new type of service, basically, where, again, the only thing that you define is two things. The image name that you want to deploy, and basically Knative will give you a name, basically, and Knative will give you a URL using that name, and it will run your image. It deploys a sidecar that it's called kubeproxy that basically will run very close to your application, and it will intercept all the requests. But it will also create a bunch of other resources behind your back, like it doesn't really matter, but it will create that route resource that basically is in charge of having a URL associated and then routing all the traffic to the proxy of the application. The main idea with Knative is that it has a networking layer that will give you access to doing other things like traffic splitting and a bunch of other crazy things that you will do with something like a service mesh. But the basic functionality is that it's going to route the request to your application, and the kubeproxy will basically inform the Knative control plane about the requests. If you have a lot of people calling your application, the kubeproxy will tell the control plane, hey, we need more replicas will be created. And as you can see, there will be, because there are multiple replicas, that basically means multiple kubeproxies, so there is something load balancing on top of this as well. If nobody is calling your route, basically what happens is like your service gets downscaled after 90 seconds or so, and basically there is a route now, there is a URL with no replicas serving requests, which is a pretty interesting scenario, and I think that this is the most interesting scenario of the entire Knative thing, is okay, what do you do when you don't have anything serving your requests? Well, you need a different mechanism that is called activator that basically is waiting for requests in order to buffer them and then wait for new replicas to be kickstarted. When you do that, you wait for a second. That's why we waited at the beginning, because we didn't have any replicas of the function. The activator kicks in, creates a new replica, and then you have a replica serving your traffic. The main idea from Knative, just to go back in track, and let's go faster to the next one, is to go from container to URL. And I didn't show that because I was restarting my computer, but if I do here the Knative services that I have, this is my function Knative service. I can describe the Knative service type. This is a new type that basically provides all these abstractions to go from containers to URL. You can see here that there is a bunch of status reports about how the function is being configured and all that stuff, but the only important bit here is that if I have an image, I can just provide you an URL, right? You can add like environment variables and other stuff, but at the end of the day, you want to run this image, and then you want a URL back so you can call this container. Important thing to mention about Knative and the Knative serving APIs is that it's being used by Google Cloud Run. Google Cloud Run provides this container as a service mechanism where you can just give them a container and they will run it without using Kubernetes or anything, and they expose the same API of Knative serving, which is pretty interesting to see. It's just the standard interface for container as a service applications. But again, this is just about serving traffic, right? Like it's about just deploying applications and then just making them auto-scale based on demand, and only based on HTTP in this case, right? Like this is just using HTTP metrics to know when to upscale and downscale. There is another project being mentioned there in Open Function, which is called KEDA, which is basically the other side of things. When you want to do asynchronous, upscaling and downscale based on, for example, messages on our RabbitMQ queues, right? So if you have messages in Kafka or something like that, it's more like asynchronous in nature, you can be monitoring these resources, taking a look at how many messages do I have in the queue, and then based on the messages that we have in the queue, we can upscale or downscale. And again, this is about running workloads. It's not about what do we do inside of our workloads. And that's what I want to talk a little bit about Dapr, which is the project that I'm currently working on that stands for Distributed Application Runtime. This is much more closer to developers. And usually I see people looking into this project when they are working in a platform team and they want to enable development teams with like a set of unified APIs that they can use to interact with complex environments. So Dapr, it's a project that I'm using in the cats and dogs example that I've showed you before, and for that I will switch. I will not switch to the other cluster because it's closed now. That's good. Things that happen. Let me see. It should be somewhere here. New window. and with my company profile, so I can show you all the secrets, restore. There you go. Probably I need to log in again. Okay, so I have kind of like the cluster where the open function stuff was installed. We have a bunch of projects installed in there, and I created a different cluster for serving the application that we used before. And there you go. So I can connect to a different cluster now. And I'm using some of these tools that I mentioned before. So we have Knative services. That's how I list my Knative services for the application. If it actually connects to the internet, there you go. And you can see that I have 3 services that are being exposed, the 3 UIs that we saw before. The ones that you used to vote, the results, and the dashboard that was showing the cats and the dogs, right? That's the side of things. So I'm using Knative there to scale things up and down. And as you will see, and as I mentioned before, the vote service, for example, because it's describe, it's a UI, I don't want to downscale it, right? So one thing that you need to understand about Knative is that you can set up boundaries, right? There is no need to downscale to 0 if you don't need it. In this case, I want to maintain 1 replica all the time, so I can do that. And also what you can do is you can, in Knative, you can define, how is that called? Like how many requests per second your application is designed to handle, right? So you can say, this container can handle 100 requests per second. If I'm getting more than 100 requests per second, I will need more replicas, so I will need to scale up. So you can fine-tune when new replicas will be created using that. Something like a common misconception is about like thinking that one pod, one container will handle a single request at a time, and this is not the case. Your container can handle multiple requests at the same time, and you can define when to scale up and when to scale down. The next thing that I wanted to show is Dapr, because we were talking about now let's go and try to enable developers to do stuff inside your clusters. And the kind of stuff that you want to enable developers to do is to basically interact with the environment that they are running with. And in this case, Dapr basically provides an abstraction that gives developers APIs to do things that distributed applications wants to do, right? So if you go to the Dapr website, which is dapr.io, you will see that we have different building blocks. And these building blocks goes from very basic stuff like doing service-to-service invocation in a resilient way, right? Like with retry mechanisms, circuit breakers, and all these things. And then like stuff that it's very common for applications to do, and that's why I was showing the application, like sending and consuming messages. Most of the application will want to submit and consume events, right? So if instead of pushing developers to learn about Kafka or RabbitMQ, I just give them an API that they can call, well, let's give them an API so they can start creating their applications faster. If they want to store a state in a state store, like a key value store or like a database, well, let's give them a database and let's not push them to learn about drivers or where the database is and all that stuff. I will just give you an API, you can start building your applications. You have then common stuff like reading configurations or secrets from the environment that it's very environment specific. So you need to use Vault, you need to use a cloud provider service, or what do you need to use? Instead of pushing developers to learn, again, let's give them an API and let's them building applications. So if you see the application that I was showing before, like with the cats and the dogs, I'm using Dapr here to basically store the votes in Redis without pushing the developer to know about Redis at all. So what I have here, for example, I have a Go service, right? So I have all the application modules in different languages, using different languages on purpose just to connect to the same Dapr APIs from different languages. And I have some, for example, if I want to save the vote in a persistent store that I don't even know where it is or what it is, I will just use a client, in this case, to connect to the APIs. So what it does, basically, is just send this request to Dapr. Dapr will know where to store it based on the environment. I've been working on some more integrations. How many Java people do we have here? Spring Boot stuff. Yeah. Okay, so a fair amount of people will understand a little bit more this example. So I've been working on this, Spring Boot integration where I can show you, more like instead of just using an API, using common Spring interfaces. Like this is a Spring data key value template that you can use, and also the messaging template, which is pretty similar to the Kafka template or to the RabbitMQ template. In this case, again, I'm storing votes by just calling the key value template update method here. I don't even care where that vote is being stored. I just want to store it somewhere. Or if I want to send a message, I'm using the same messaging template send, and then I'm just sending my vote somewhere, right? And it's going to be sent, and somebody else can consume it from there. Interesting enough, like now, because we don't have Kafka, Redis, or RabbitMQ dependencies in my application now can be moved across environments, even if I'm using, for example, managed service, provided services, for example, for Google PubSub for messaging or Amazon SQS. I can just change the Dapr configuration behind the Dapr APIs just to connect to those services without changing my application. So how does it work? I want to show you quickly some diagrams if this works, because I'm now super scared that this will not work. So how does it work? So you deploy your application. You can be using Knative, or you can be using just the normal Kubernetes deployment. Then you annotate your application with a specific annotation saying this application wants to consume the Dapr APIs. And the Dapr control plane will basically inject a sidecar that exposes these APIs to your application. These APIs are exposed via HTTP and gRPC, so your application can basically be sending HTTP requests to the Dapr sidecar or use one of the SDKs like I was showing with Go or with Java just to connect and do that connection. This is a bidirectional connection that basically means that you can send data or receive data from Dapr, right? In this case, when you connect to the Dapr sidecar, Dapr will read to some environment configurations about how these APIs, if I want to store state or send messages, are implemented with real infrastructure. So what I have in my environment is basically configured that for messaging I want to use RabbitMQ, and for storing state I want to use Redis, right? So the Dapr sidecar will connect to this infrastructure, and it will allow me to run my applications in the cluster. And because now I have unified interfaces, that basically means that, again, I can just move my infrastructure to Google Cloud Managed Services, and my application will not change. I just only need to change the Dapr configuration for how these APIs are implemented. The same with AWS. I can just switch to AWS, or I can switch to Azure, and I will have different implementations for all these environments, making my application a little bit more stable and portable across environments. It's not that you're going to be moving your applications from one cloud provider to another, but think about like running your application locally with local infrastructure and then moving into the cloud with managed services. The API is the same. And because we have sidecars, every time that you have sidecars, you can do a bunch of things, as I mentioned before, service-to-service invocations. You can have discovery, but you can also have retries, circuit breakers, and a bunch of other things. Like, for example, security. You can add MTLS connection between the two sidecars, and all the communications now will be handled by that. Because you are observing traffic between infrastructure and other services, then you can get like a unified view of logs, metrics, and traces about how your applications are consuming infrastructure, how much time infrastructure is taking, and exactly what your applications are doing against that infrastructure. So you can troubleshoot easier because you have a single view of what your applications are doing. From a Dapr point of view, again, I've showed you a bunch of things. Usually this project will not make any sense unless you go and give it a try. If you take a look at the book, it has a bunch of repositories that are basically showing all these projects in action, so you can run them in your own laptop and experiment with an example application. Not similar to the one that I'm showing here, but like it's close enough. And again, this project makes sense when you try to enable developers to just do more stuff without learning about complex environments or learning about cloud provider stuff. This does separate, the infrastructure from your application code, and I didn't show that, but if I go here to the application, I can list all the Dapr components. It's another Kubernetes resource, components. Another Kubernetes resource that basically is defined there. I mentioned before that I'm using Redis, PostgreSQL, and RabbitMQ. So I have two what are called state stores configured to connect to PostgreSQL and to Redis. I can describe one of these. And you will see that it's very basic configuration, which has like two things that are important, like type. That's the implementation type. So if you want to move this to Google, in-memory database store, right? In-memory data store or something like that, you just need to change this type and then just provide the credentials here so it can connect to that service in your Google Cloud account, right? And then it has a bunch of other parameters, but those are actually not important. This is how you index data here. Maybe you want to add some hints on how to index data. And I have the same for RabbitMQ. Again, I have a RabbitMQ instance running here. So if I didn't show you that, but like I have a RabbitMQ instance, a Postgre instance, and a Redis instance running here in the cluster. That's Redis. I think that's Postgres, and that's RabbitMQ, right? So the only thing that I'm doing is I'm telling Dapr, hey, these components are here. Just connect to the local instances. And if actually I want to start moving these services to Google Cloud because my application is running on Google Cloud, I just need to change those configurations there. Just for completion, let me show you components, the RabbitMQ one, so you see that it's basically connecting to that instance. Again, the only thing that I wanted to show here is the type, basically, that basically tells you, this PubSub API of sending and consuming messages is implemented by RabbitMQ. From the application point of view, I don't care, but from the infrastructure point of view, I need to connect to RabbitMQ, so I need to know where the RabbitMQ hostname is and the user and the password to connect to it, right? That's just pretty much what you need to know as from an infrastructure side of things. Again, because it's a Kubernetes resource, you can start defining environments in Git, right? Like you have all these definitions on how to connect to infrastructure defined in Git, and then use something like Argo CD to replicate this environment somewhere else. And I think that's kind of like what I wanted to share about Dapr. Again, trying to share some kind of like the main points and some examples quickly so you can go and research more if you're interested in that space specifically. To finally arrive to something that OpenFunction is not using, but I think that it's also important to mention. Because I've been talking about clusters, I've been talking about infrastructure like databases, message brokers, and also like deploying the application, but I haven't been talking about creating and provisioning infrastructure. If you're working with any kind of application like the one that I'm showing that is running on a Kubernetes cluster, you will need to manage and create cloud resources, including Kubernetes clusters, right? Who created the cluster that I'm using? Well, you probably will be trying to automate that using a tool like Crossplane or Terraform or Pulumi are the ones in the space. I'm usually concentrated on Crossplane because Crossplane extends Kubernetes. And I think that that's a very important difference compared with all the other competitors. So for certain use cases, that makes a lot of sense. So again, we had our application running in a cluster. We had Knative and Dapr installed there, and we have a bunch of infrastructure. So who created all that stuff? Somebody needs to create and configure these environments in a way that it's reproducible, but also simple to use. So a platform engineer can use something like Crossplane, that is something that you will install in your clusters in order to provision cloud resources or resources in general. It's interesting because Crossplane is not using Kubernetes as most people will use it. Like most of us will use it just to run workloads. With Crossplane, you basically install Crossplane in a cluster where you are probably not going to run your applications. You will have a management cluster that is in charge of provisioning resources, but not running your workloads. Your applications will be not running in that cluster. At least you shouldn't do that, I think. The main reason why is that is because this cluster will have credentials to connect to cloud providers and provision resources on your behalf, right? So what I did for my cluster is basically I installed Crossplane in a cluster, then I installed a GCP provider, so actually Crossplane can provision new resources for me. And how does it do that? It basically extends Kubernetes with custom types for cloud providers, right? So you can have something, for example, like the cluster resource or the database resource or the message broker resource for Google Cloud. Then you create a YAML file that basically represents the resource that you want to create. You send it to Crossplane. Crossplane will create these resources for you, and it will keep monitoring these resources to see if they are created and running all the time, and it will report status back. If you go and delete the resource, Kubernetes will create it again in the same way that it will create again a pod if you delete it when you're running your applications. So it's a little bit different model, and it also opens the door for more like multi-cloud or cross-cloud kind of scenarios where you can have multiple providers. It's not that you will only have your Google Cloud provider. You can have Google Cloud, AWS, Azure, and then send resources and create stuff across different accounts, which is kind of like interesting. I wanted to show you quickly, I think, again, I don't know if this will work, but let's give it a try. So I have Crossplane installed here, and I have the GCP provider installed. You can get the providers. And you will see that, yeah, I have provider GCP SQL. That basically means that I have a bunch of resources related to databases that are installed here. I have here the directory here with just a simple YAML file, which basically describes a database instance for Google Cloud, right? So this resource basically allows me to say, hey, I want to create a new database in my Google Cloud account, and I want to send these parameters. I want the PostgreSQL 15 to be created, and I also want to have a way to connect to it, so I need the URL for that database and the user and password that I will need to connect, the kind of database, how big it is, in which region, all the stuff that you will need to define when you are creating a database, right? And because I have Crossplane installed in my cluster, basically I can just apply this. I think that I need to create. This is using some weird stuff for generating names, so you cannot apply it, you need to create, so it will just generate the random name. And basically what I do is just send this request to the cluster, and then basically Crossplane will provision a new database in my Google Cloud account. In a way, what Crossplane is doing here, and I think that I have the screen somewhere here. So if I go to my Google Cloud account, and if this is working, which is might not, but let's check. So if I go to Google Cloud SQL, what I'm doing with Crossplane is basically, there you go. So I'm just codifying a way to create resources into Kubernetes resources. So I create a Kubernetes resource which basically allows me to enter pretty much the same information that I will be able to fill here into a form in order to create this database. But what Crossplane is doing is automating all the process of creating and monitoring these resources, which is pretty useful in general if you are building complex infrastructure, right? When I'm creating a database, usually I don't want a database. I want a database, I want a network, I want probably some keys, I want a bunch of different things in order to be able to access that. Probably I want like a role somewhere so I can have access to write tables and do stuff like that. So usually it's not that I want to just create a single thing. I just want to create a group of things and they need to be linked together. And that's where I think that Crossplane actually nailed it with their definitions and their mechanisms. And they created something that it's called composition. So if you go to their website, crossplane.io, and look for compositions, basically what they allow you to do is to create these composable resources when you can say, I want a cluster, a database, and a message broker, and that will be my environment. And now environment becomes a Kubernetes resource that only exposes the thing that I'm interested in defining when I'm creating a new environment. For example, if I'm a developer and I want to test my application, the one that we deployed, maybe I just want a development environment. So I can just send a single resource saying development environment, and you get all the things like a cluster with Knative installed, Dapr, and Redis and RabbitMQ all running for you to deploy your application. I think that mechanisms like this that allows you to create interfaces and create abstractions without actually creating a controller are extremely powerful, and I think that that's the main reason why Crossplane is so popular nowadays into the CNCF space. I strongly recommend you to check it out. Again, in the book there are like a bunch of tutorials where you just will go and use Crossplane in different ways to create abstractions and to deploy these abstractions in a local cluster. And that will give you a different insight that when you see it in a presentation, it kind of makes sense in a way. Maybe you're using Terraform, or maybe you're using some other tools, but when you actually have some hands-on experience with the tool, you actually realize how powerful this is and how other use cases you can tackle with this. And at the end of the day, I've seen many people using Terraform for provisioning some stuff and then going into Crossplane for doing the management of these resources that are a little bit more sensitive or more where you need just to fine-tune some things that you can do with Terraform, but it's much more easy to manage here. So Crossplane, again, basic stuff, you create infrastructure using Kubernetes resources. More advanced stuff, you create higher level abstractions that you can use to expose your interfaces that are more specific to your domain. Looking into compositions and composition functions is a key thing on the project, and they have been doing great with that. And I've seen a lot of companies just picking Crossplane for those capabilities. And the other thing that you can do with this is now, because you have some kind of like packaging mechanism to say all these YAMLs and all these compositions and all these abstractions can be packaged as containers. So I can just package everything as an OCI image, share it with another team that can install it in their Crossplane installation, and start using these resources, make it even more attractive for platform teams to share knowledge and share these abstractions across different installations. So I strongly recommend to check that out. I'm running out of time now, but I wanted to mention this because I think that this is super important. If you are building platforms, don't build the platforms on your own. Just go outside and check what other companies are doing. I mentioned Knative serving here, and I needed to mention this because again, it's a very mature project that does one thing and does it well. do the auto-scaling of HTTP-based workloads. It's been adopted by companies like Red Hat in their OpenShift suite and VMware Tanzu. They both bundle Knative in there because, again, it's mature and it's being used a lot for those particular use cases. And as I mentioned before, Google Cloud runs the same APIs for their containers as service service, where the main idea there is just to simplify, the experience of, running containers without needing to know or needing to create clusters that basically cost a lot of money and you need to maintain them. So check that out. In the case of Dapr, I mentioned, these unified interfaces for interacting with infrastructure and building distributed applications. I need to mention that Dapr was created by Microsoft in 2019, and it's running as part of container apps, Azure Container Apps. So if you're running containers on Azure, you already have the Dapr APIs already there. They are running Dapr as a managed service there. And again, if you are using Azure, you just are halfway to be able to use these across teams. And in the company that I'm working on right now, Diagrid, we offer 2 products for managing Dapr at scale when you're not running on Azure and you're running Dapr yourself, and Catalyst, which is basically a multi-cloud approach for running these APIs without pushing you to manage these services. And finally, Crossplane. Crossplane is being, has been created by Upbound, the company, which basically offers, managed services on top of Crossplane that you can run on their cloud or you can run on your own accounts in your own clouds, which makes a lot of sense for a lot of companies. I've seen very, very large companies running these services inside their compute because most of the time you don't want to delegate, this to an external service like, for example, Terraform Cloud. Again, building platforms is hard. I wanted to show Open Function at the beginning because it's a very complicated project that does a lot for you, but when things go wrong, you need to learn about all the tools that they are using. I wanted to show each of the individual tools that I've seen being used by platform teams when they are trying to simplify their operations for development teams or for operation teams. And I keep saying this because I think that it's the most important topic. You need to build your own abstractions and you need to focus really, really hard on what to expose and what not to expose to your teams. If you want to simplify their job, you just need to make sure that you have that right. And again, platforms are not about adopting technology just for the sake of adopting technology. Just try to measure, if you are simplifying the life of users or not. And in order to just actually do that, you need to prioritize what are the challenges that they are facing. So adding Crossplane because you like Crossplane will not make sense unless they are having an issue with provisioning infrastructure. And again, don't do it alone. There are tons of companies building products out there. And most of these are related to open source projects, so they are more than happy to engage with companies implementing these solutions and help them to integrate, with different tools and the entire ecosystem. So thank you very much. There is a discount code there if you're interested in the book, and I will do that now because I have 1 more minute. So let's do that. So I have 2 copies of the book, and if you bought it at the beginning, and if the window, of course, it's not open anymore because it's not here. But I'm using Kubernetes, so I should be able to get this sorted out, right? It should be here. There's an URL somewhere. And let's see if this works. I'm just not trusting my computer anymore from now on. So if you still have it, you can see that that's working. I know that dogs win, I think, but drumroll, let's see if we can find a winner from the voters. Check your hash code. If somebody has that hash code that I just click and deleted, there you go, that hash code. If somebody has that one, you get a book. Do we have it? Okay. Yes. Okay, we have 1 winner. That's the cat's winner. Let's do the dog's winner. And my computer doesn't have the mouse anymore. There you go. Dog's winner. Drum rolls. You cannot win 2 books. That's the only thing that I'm saying. Does somebody has that one? Hey, there you go. Congratulations, guys. Thank you very much for your attention. And apologies for my computer freezing. I cannot do anything about it, right? The clusters are working, which makes me happy. So thank you. There you go. Any questions or things? Please feel free to come and ask directly, right? I will be around today and tomorrow. So I think that's it. Thank you. There you go.